3-day course is primarily to get you all up to speed on AWS and give you a good solid foundation on on learning AWS services, and you be more confident, and then you kind of make use of that for your career advancements, for your career path, right? So that's the whole idea. So what we thought was that we will get started with AWS today, and uh, and then for Python, we can actually take a detour somewhere in the middle when we actually start doing some hands-on experiments around automation, right? That's when we will take a slight detour for about 2 to 3 days, and then I can introduce you to Python in the context of AWS, right? So that that you're applying that somewhere instead of writing a hello world program, right? I don't want you guys to just simply write an hello world program and then be complacent about it, right? So that's kind of not the real learning. Of course, that's the first step in learning, right? But I'm sure all of you uh, got a sense of how things look like by now, right? We have gone through 2 programming courses till now, right? So one on Oracle, which Brother Ravi took, and then last week we went through on the shell programming, shell scripting, right? So rather, I do not want to again repeat the same mundane things of having you guys write a hello world program in Python and then get bored with it. So rather, what we'll do is we'll get started with AWS somewhere by say next week or week after next week. When we actually start automation, when we start dealing about the automation topics on AWS, that's when I'm going to take a detour for about 2 to 3 days and then introduce you to Python, and then make you do some real examples using Python on AWS, right? So that you are able to understand the use case much better, and you're able to appreciate, where it is actually being used, right? So that way, I'm sure, you'll be able to make better sense out of it, and you'll be able to empathize with what is the real value of learning a language named Python and applying that in the context of Humpty number of things, right? One being AWS. Okay, all right. So I think about 74, 75 of them have joined. So let's get started. What I'm going to do is I'm going to spend about 20 minutes to half an hour in giving you an orientation on what cloud computing is all about, right? I'm sure most of you would know what a cloud computing is, and a lot of you, in fact, I've seen somebody already, working, playing around with AWS, right? So that way, we will get started with, what a cloud computing is. That's basically the foundations and fundamentals, and then we'll get started with AWS, and then maybe from tomorrow onwards, we can actually start doing some hands-on exercises on AWS. So I have got a slide deck. Let me just bring it up. I hope my screen is visible and my audio is clear.
Yes, we can see and listen to your audio.
Okay, great, excellent.
I see recording. Yeah,
okay.
Sorry.
Okay, let's get started with introduction to cloud computing, right? So what is computing? All of us know what computing is, right? And what is cloud computing, right? I mean, what does the term cloud refer to? Right? What is the term? Or forget about the term cloud. You see a symbol cloud, right? Like the cloud symbol, right? So you come across that in a lot of white papers and a lot of day-to-day things, right? So what does that symbol cloud represent? Right? I mean, that's something that let's first understand that, right? Let's get into understanding that as a fundamental, so that you'll be able to appreciate what a cloud computing is and what is the difference between a cloud computing and a non-cloud computing, right? So that's very, very important. Okay, so the objectives of this specific session is to understand the fundamentals of cloud computing, its characteristics, what are the various different service models that cloud computing offers, and what are the various different deployment models that are available in the form of cloud computing, right? And also to understand the various myths and challenges of cloud computing. I mean, industry has got a lot of myth around what cloud is, what cloud is not, and things like that. So how do we understand that, and how do we demystify those? Okay, before we actually get into cloud computing, okay, let's look at few other things, right? Okay, all of us consume electricity, right? And all of us use the public transportation. All of us use um, telecommunication, like mobile phones. Of course, public PCO booths no longer are there because of the rapid development of mobile phones. But yeah, again, public phone booths that are there, right? And all of us use mass transportation. All of us use, uh, you know, a common network, satellite systems for various things, right? Satellite for streaming video directly to the home, right? Such as your DTH, direct to home TV channels, right? And satellite connections and so on and so forth, right? So now, I mean, a lot of these that you see here are all public utilities, right? We call them as public utilities because they are publicly available, right? For example, if you take a satellite, nobody launches a satellite, nobody spends millions of dollars to launch a satellite only for their personal use, correct? Where a space agency or a space organization at a country level or at a space organization basically launches the satellite and which is shared by masses, which is shared by millions of people, right? And similarly, train. Let's take a train service, right? Train service. Nobody lays the tracks, builds the railway stations, and then build a train coach for personal use. Correct? It's not needed. Okay. Similarly, electricity. You have the electricity grids going right around the globe. Okay, so let's take only India and then let's take only Telangana and Hyderabad, right? Hyderabad has got so many power stations and Hyderabad has got so many grids, right? And all of these grids are interconnected. And in some way, this grid is also connected to the national grid. Okay, that's the project that was taken up a few years back to connect all the states to the common national grid so that states can share the electricity. If a state has got a surplus electricity, they can actually share it with the next state, right? And that way, they can sell the surplus electricity that they have that they produce to the neighboring states, right? And they can also benefit out of it. And if the neighboring state does not have those many power generation stations, you know, and if they have so much of demand within their state, they can actually borrow it from the next state and pay some lump sum amount to the next state, right? So that's again an example that we see on a day-to-day basis. We are not. This is not something which is new, right? We have been using this, and we have been. And as an individual, right? As an individual, I have got a flat, an apartment, and I've got a electricity connection to my apartment, and then as much as I consume, I pay for it, correct? But in order to have electricity at my home, I don't produce it myself, right? And in order for me to uh, say go from say here, if I want to go from Hyderabad to Delhi, right? I don't own an aircraft. I mean, of course, there are people who own aircrafts. That's a different thing. But for private chartered jets and things like that, I mean, let's keep those. Those are outliers. But I'm talking about masses, public, common people. They just go. They just use a public utility such as a train or a flight, right? And then or a bus, and then they pay for the seat that they have reserved, and then they travel from Hyderabad to Delhi. So similarly, in the way back in before in the 1900s, when computers were invented, right, and when computers were used for solving, a lot of challenges, solving a lot of problems. That's when in 1960s, John McCarthy, okay, John McCarthy is a computer scientist. He thought that, I mean, why can't computation be organized as a public utility, like how you have power grids, um, train service, right, satellite communication and things like that. I mean, why can't computation be sometime organized as a public utility, right? So that's when this whole thought of cloud, uh, was basically seeded at the back in 1960s, right? So where did the term cloud come from, right? In 1990s, when telecom companies commercialized large networks by offering VPNs, right? All of us know what VPN is, virtualized private network, right? Um, for telecommunications, using the advancement of the internet, calling them telecom cloud, right? So now let's 1960s, John McCarthy, thought that computation can someday become a public utility rather than being a private thing, right? I mean, if I need compute power, right? At the end of the day, I need compute power, right? Say, let me give you one more example. Like, for example, you have Amazon.in, right, or Amazon.com, and you've got this Prime Video where you stream millions of users stream at the same time, right? And you have Amazon.com where millions of users place transactions, place their orders, right, on a daily basis. If you see, there are millions of transactions that are placed, and then Amazon delivers those through their e-commerce platform, correct? So now, in order to basically support millions of transactions, imagine how much compute capacity is required, right? Let me take you to the example of last week. We were trying to do a few examples on shell programming, correct? I mean, we ran very simple shell scripts, um, like if else condition using while loop, for loop, and things like that. Now, when you run those shell scripts, what actually happens behind the scenes is the CPU is used, and the memory is used, and the underlying network is used, correct? So these are the three fundamental things. CPU, all of us know what CPU is. All of us know what a memory is, correct? And all of us know what a network is. So now these are the fundamental ingredients of a computer or a computing system. I'll not call it computer anymore, because just calling it computer restricts it to one system, right? All of these are ingredients of a computing system. So now, when you take this computing system and when you want to run a simple shell script, probably you need some amount of CPU cycles so that the shell script can run. It can use the memory which is allocated, right? Probably to run that for loop, maybe you need about say 10 MB of memory, not more than that, or maybe 5 MB of memory, or even less than that. Okay. So now, in order to get that 5 MB of memory and then few gigahertz cycles of compute time, when I say compute time, the CPU's time, right? Because when you enter a command in the system, what happens is CPU takes it, CPU processes it. It's like if you all have come across microprocessors in your colleges, then you know how microprocessor works, right? And how 8086, 80386, 80486 architectures work, right? And I'm sure a lot of you would have done some experiments with maybe the 80386 boards that you would have, where you would have programmed that board using the commands that the 80386 offers. So now, coming back to the topic, so the processor, the microprocessor, would need to take the inputs from the end user or the user, and then it needs to process that input, and as part of the processing, it needs to store some data into the memory, and also it needs to store some data on the disk, or process the data from the underlying persistent disk, right? And then it's a combination of everything, and then it needs to send the data back to the user through the network, right? So now, what are things are there? One is the compute, the CPU. Then you have the memory, where the memory will be used to process the data. It will consume some amount of memory. Then you have the underlying disk, where data is stored, persisted, or data is stored permanently on the disk, right? Even after the program gets executed, the data is present in the disk. and the fourth one which is required is the network, correct? So these are the four ingredients of any computing system that is needed, right? So now what happened in 1990s is that okay, so I was talking about the Amazon example, right? So now imagine for running a simple shell script, you need, you know, some amount of compute capacity, memory, disk capacity, and network capacity. Imagine a large internet scale website like Amazon.com, Google.com, right? Things like these, which are accepting millions of transactions per minute. Imagine how much of capacity they would need to process that data, to ensure that, the moment I open Amazon.in, I get a quick response time, right? Oh, I'm sorry. I think I stopped the screen share. Yeah. So the moment I just opening Amazon. Yeah, just opening Amazon.in. See how quick. Probably not. It didn't even take a second to load this page. Correct. Now that's the user experience that websites like Amazon, Google. I mean, some of these websites give you, right? Some of these applications give you. See, Google also did not take even a second, right? So now, what goes behind the scenes, right? I mean, if you need to build something like this, and if you need to actually give the same amount of user experience. Now imagine if I open Amazon.in and I wait for 20 seconds before the page loads. As an end user, I will get frustrated, right? It will basically degrade my user experience, right? So then I would say, Arey Baba chhod do. I mean, Amazon doesn't open properly on time. I will go to some other website. I'll go to Flipkart, or I'll go to some other website for online shopping, right? So that's a potential business loss, right? So now at the end of the day, if you have to keep your end users happy, you have to give the right quality of service to the end users, correct? So now from that perspective, imagine how much of compute power that Amazon should have, or that Google should have, or Flipkart, or Swiggy, or Zomato's, or Uber, Ola, right? Airbnb, and all of these people should be having, right? Not only that, I mean, these are just some of the famous examples that I took, right? There are Humpty examples, where the websites respond much faster, and it basically helps end users perform what they want to do, right? So now, coming back, right? So now that's the power of the compute, right? And of course, you need the right capacity to ensure that you're able to satisfy your user requests. So now, in 1990s, when telecom companies came into existence, like in India, if you take a BSNL, right? BSNL was the first telecom company in India to kind of bring. Before that, we had the Department of Telecommunications, right? It was all government owned. Then BSNL came. Then a few other companies came like Airtel, Vodafone, and off late Jio is very, very popular, and Jio has basically disrupted the entire market of late, right? And if you take globally, if you take AT&T, Verizon, right, T-Mobile, right? So these are some of the Vodafone, right? So these are some of the global companies, Singtel, right? So these are some of the global telecom companies which have created a network around the globe, right? And as part of the network, you can make use of that network, a portion of the network, I would say. I mean, even now, right? I mean, when we connect, when we make a phone call to somebody, that network is not dedicated only for you, correct? There are other people who are using the tower. I mean, probably there could be a tower close by to your house, from where you're making the call, and it connects to that tower. And then once it connects to the tower, it basically gets connected to your friend, to whom you're trying to make a call, right? And that's how you. So it's basically shared. It's a shared resource, right? It's not a dedicated resource, right? So that way, the term cloud itself came in 1990s to represent the companies, the telecom organizations which commercialized large networks, through which companies could connect their network, right? Say, let's take an example of a company, who's having a head office in, say, Hyderabad, and they have got branch offices in multiple locations within Telangana or outside of Telangana in other states as well, right? In probably Chennai, Bangalore, Mumbai, Kolkata, right, Pune, places like this, right? And they want to create a private network connecting all these branch offices together, right? In such cases, what they will do is they will go to probably one of the telecom providers like Jio or Airtel or BSNL. And then what BSNL would do is BSNL would, connect all these branch offices through the BSNL's network. Okay, but that's called the VPN. That's called virtualized private network. So that it will use the common network which is there, but at the same time it will be whatever they transmit through that common network will be encrypted, right? And that will it'll look as if the whole net you're sitting in one network, even though the branch offices are spread across multiple different locations. A person sitting in Bangalore office would be able to communicate to a person sitting in Chennai office or Hyderabad office as if they were sitting close to each other, right? So that's the concept of virtualization. Okay, so that whole notion of cloud came up during that point in time, where it was used by the telecom companies, right? And today what we have is cloud computing, right? So where we have uh, resources available on the cloud, on a public cloud. Okay, we'll call it public cloud, right? So it's basic. When I say cloud computing, it is public cloud because there are different models of cloud computing also there. So that's called a public cloud. So now you have cloud computing. Today we have cloud computing where we can provision resources on the cloud, right? And we'll be able to provision some storage on cloud, provision some compute on cloud, right? And there are multiple different models that are there. And these are some of the examples like Amazon Web Services, Google, right? Azure, Windows Azure, IBM, right? And Salesforce and things like that, right? So now, and there are standard definitions of what cloud computing means. In fact, NIST, okay, National Institute of Standards and Technology, right? So they have defined what a cloud computing stack means. What does a cloud computing means, right? So you all can go through that. You'll get a better understanding of it, right? Now let's look at how the cloud computing evolved from 1960s or 1970s to now, right? So now, so in 1970s, like grid computing what was started, right? So where grid computing was about private organizations, private companies, they connect all their equipments, all their computers, all their offices, through a common network, right? And then, they were able to globally connect all their systems together. So that's called grid computing. So that was mainly used for uh, solving some scientific challenges. Okay, when you are trying to find today in the world, a lot of people are trying to find answer for infinity. Okay, infinity we know all of us know what an infinity is, right? Infinite means, right? Now there's a lot of research happening to basically figure out what infinity looks like and how infinity can be understood, right? In a scientific way, right? So now for that you need a lot of uh, compute power, right? You need a lot of compute power. And today in today's world, all of us know about bitcoins, right? Bitcoins and mining bitcoins, right? That you give us there's a certain algorithm, then you use that algorithm to solve a mathematical challenge, right? So bitcoin mining happens in the web, in the internet today, right? So now all of those are examples of grid computing. So grid started initially, but again that was not so widespread and people were not able to use grid. Only, as I said, only scientific companies, scientific organizations used grid computing to run the parallel processing, and they had high performance computing clusters available, with which they were able to basically solve some complex challenges which otherwise would have taken ages. Okay, but common masses like you and me were not able to make use of that network, or we were not able to make use of that for our day-to-day lives. So then in 1990s, web-based utility computing came in, right? .com. Okay, 1990s, probably early 1990s is when websites started coming up, right? So where you could basically go to you if you had an internet connection, you were able to use that internet connection in probably mid 90s, and then you were able to browse the internet, right? So that notion of browsing the internet actually started in 1990s, right? So then Then what happened was that time in 1990s, I still remember, when I first took my very first internet connection, it was not broadband, it was not so sophisticated like what we have today, right? In 1990s, when I first took my internet connection, it was um, a phone line, a normal telephone line, and in that phone line, you get the internet connection. It's called a dial-up internet connection, where you dial into the phone line, right? And then you'll be able to make use of that phone line as your internet connection. And then speeds would be so pathetic speeds, right? And it'll hardly be 1.52 mbps. Today we have 150 200 mbps, right? It has it has grown multifold, but in those days, 1.5 mbps to basically use the internet, right? And then way back in 1990s itself, the metering started, right? So basically, if I used internet for 1 hour, whatever the landline provider would charge you, right? For example, I had a BSNL line, and every minute the BSNL would charge about 1 rupee. Okay, for every minute, every 60 seconds, they would charge 1 rupee. So now, if you used 60 minutes of internet, okay, because it's like 60 minutes of using your phone line, then you would be charged 60 rupees. Okay, so that was the kind of utility based computing that came up in 1990s. Okay, so then in 2005, 2006, so that's when the actual cloud computing started, right? So where you could actually, as an end user, and then the networks also improved. Then there were so many advancements that came up, right? Networks became much better, much efficient, much cheaper, right? Then mobile phones came up, right? And maybe in 2000s itself, mobile phones came up, right? So now network based subscriptions to applications and usage based pricing came up, right? And Gmail, I still remember, I created my Gmail account in I think 2004, 3 or 4 or 5, somewhere around that time. Because those days, when you had to create a Gmail account, it was not, you could not just go and create a Gmail account. Somebody who had a Gmail account should invite you and send you an invitation, and then you enter your details, and then you would basically get a email from Google saying that, okay, you can provision your account, you can create your account. It was all on invitation basis. So I still remember that I had created my Gmail account on an invitation basis. One of my friends sent me an invite, and I created my Gmail account, right? So that is a classic example of subscription based, network based subscriptions to applications, because Gmail is an application, right? So now Gmail is available on the internet as a cloud, right? And you would be able to basically subscribe to Gmail and make use of it. So behind the scenes, they take care of all the processing that is required to run the servers, run the amount of storage and things like that. But it's all usage based billing, right? So then in 2006, is when the actual notion of real cloud computing started, right? So where Amazon came up with this whole idea of uh, you know setting up a public cloud, where anybody who has an internet connection could subscribe to Amazon Web Services, and they can create an account with Amazon Web Services, and they would get a console. The console is nothing but a web page. They would get a web page, and that web page they can go, they can create the necessary compute power that they need, compute and storage power that they need on a on-demand basis. Okay, it's all on demand, right? You go, open the console, you say that this is the specifications I need. I need two CPUs, and I need 4 GB, and I need 30 GB of storage space, 30 GB of disk space, and I need so and so operating system. I need so and so network interconnection, right? So you could just go, and you could do a self-service provisioning. You don't have to have any knowledge of uh, prior knowledge of how you need to provision, how you need to choose, and things like that. Because Amazon came up with the concept of giving you a service catalog. Okay, service catalog is nothing but it's a catalog which had canned services available. You could go select that services. With a little bit of knowledge, you could just go provision something, and you can deploy your application, or you can deploy, you can run your program, or you can run your code in about 10 minutes time, right? You don't have to wait. Okay. And that too, it's available on the internet, right? And you could basically expose it on the internet. So Amazon takes care of everything, like your compute power. When I say compute, so guys, just remember all of this very clearly. When I say compute, I mean CPU and memory. Okay, that is the basic fundamental. And when I say network, it is basically the network communication that goes through. It can be the private or the public network. And when I say storage, that is the underlying disk, right? You have your laptops or desktops, you have a CPU, and you have memory, and you have a hard disk attached to your laptop or desktop, right? So that is the storage. So compute is CPU and memory, storage is your hard disk, network is your network, the network interface where you would have plugged your LAN cable, or you would have connected to your Wi-Fi hub or Wi-Fi router, right? And then in turn, the Wi-Fi router connects to your modem, or it connects to your cable internet provider like ACT or BSNL or Airtel or whatever it is, right? That is called the network. So since you have all of this, you're able to attend this session, right? Otherwise, you wouldn't be able to attend this session through Zoom, right? So now remember these, three terminologies very clearly: compute, storage, and network. Okay. So now that's when Amazon came up with this idea, and then a lot of other companies also thought, and a lot of companies like Microsoft, Google, and they all came up with this, with their own services, their own flavors of cloud computing. Okay. And then it actually started taking shape in like about 2010 2011 times. That's when the notion of public cloud became so popular. Lot of organizations, lot of enterprises, wanted to adopt cloud computing. And today what you see is, in 2020, maybe about 15 years down the line, what you're seeing is cloud is the new normal. Without cloud, the world doesn't exist today. Without cloud, companies don't grow. Without cloud, businesses don't grow. Okay, there are humpty number of examples for that. Like, let's take services like Uber, Ola, Swiggy, Zomato, Amazon.in, Hotstar, right? Amazon Prime, right? You take any large scale internet based service which is being used by masses. I'm not talking about one or two individuals using this. I'm talking about masses. Millions of people are using this, right? When millions of people would need to use this, obviously the scale also has to be much higher, correct? So, and the reach has to be much higher, right? So all of these organizations, trust me, my friends, they're all using cloud, they're all using public cloud. Okay. And today we are in a stage where public cloud, without public cloud, none of these would exist. Without public cloud, in fact, the call that we are currently doing, okay, through Zoom, would not exist. Okay. Without public cloud, you would not get you would not get online shopping delivered at your doorstep. Okay. Without cloud, you would not be able to uh, at a single click, you would not be able to order uh, a cab. Okay. Without cloud, you would not be able to, with a single click of a button, you won't be able to order food. Okay. And without cloud, you would not be able to send your favorite pictures or your selfies to your friends, or in your social media. Okay. All the social media that you see, it is all using cloud at the end of the day. Okay. Now that is the power of cloud computing. So I want all of you to understand, where it fits. I mean, don't think that cloud is one small thing which is sitting somewhere, and cloud is so and so. I mean, that picture is not going to help us. Okay. Imagine cloud as the scale. So basically, cloud computing is a business and economic model. As I said, it's an economic model, right? For example, today, let's take Olas and Ubers of the world are able to actually economically are able to provide the service. That's because of cloud. I mean, because they get inexpensive, they get very cost effective utilization of compute power on the cloud. They're able to pass on that benefit to the end users, right? So that way, you're able to basically pay only for how much you use on the cab, right? So which also includes the includes their app cost and things like that, right? Not only the cost of the car and the driver cost, right? It also includes the app cost. And it's also the next generation internet computing, where anything that you see on the internet, in some way or the other, they are related to the cloud, and they're all like next generation data centers. Oh, okay, what is data center? Okay, data center is a place, it's a place where you uh, have your servers racked and stacked, right? So that's a place where you have uh, it's a huge real estate. Okay, I imagine like a huge real estate where they have multiple racks. It's called racks. In fact, I'll show you an interesting video of how a data center looks like. But it's a huge place, where uh, there are multiple racks that are kept. Racks are nothing but it's like our cupboards, right? Like our um, huge cupboards that we have at home, right? The steel cupboards that we have, or the bureaus that we have, right? So almirahs that we have. So it's like that, and each rack would have multiple servers in it, right? Server is nothing but they're computers, which has all I spoke about, right? Compute, storage, and network. These are the three ingredients of a computer. Like how you have a car, you have a chassis, you have a wheel, you have wheels, you have steering wheel, you have an engine, right? So these are the four things that are required in a car, right? So these are the four fundamental things required in a car. So then all that you add is additional thing, right? Of course, you need brake, accelerator, and clutch. But yeah, leave that aside. But these are the four key ingredients that you need, right? So similarly, in a computing world also, you need these three things: compute, storage, network, as a basic ingredients of this thing. And if you actually have a server, what is a server? A server is the one which actually can host multiple applications, and it can run more complex things, right, than a personal computer. A personal computer is all our laptops, desktops that we have at home. I mean, you can't really use that as a server because they're not server class computers, right? So they're all personal computers, right? They can only take so much of load. They won't be able to take load beyond a certain point, right? And it's meant for your personal computing. They're all personal computing devices. But if you have to roll out a service like an Amazon.in or a Swiggy or Hotstar and Uber, then you can't use your laptop, right? You can't host your Amazon.in on a laptop, on a bunch of laptops, say 100 laptops. It won't support, correct? Because it's not meant for that. So you need a proper server, which is the enterprise grade server class machine, right? Which has much more solid this thing in it, solid resilience in it, and which is able to support the compute power that you require, right? So that's called the server. That's called data center. But I'll just show you a quick video of how a data center would look like. Okay. Okay. Let's look at this. I'm not sure if the audio will be visible. Uh, so will the audio be visible? Audio be audible? I, I'll
No,
play
an
this
audio is not audible.
audible. No? Then okay. So how do I play the audio?
Actually, when
Okay,
you
let me put it on speaker. Okay, let me just put it on
no,
speaker. I think then it will be audible.
no, you can stop sharing, reshare your
Okay.
screen, and there is an
Mhm.
option at the bottom like share computer sound. So if you select that, we can
Oh,
hear
okay.
the audio.
Okay. Okay. Sure. I'll do that. Okay. In advanced sharing options, right?
No, it's a regular. Click on share screen.
Got it. Share computer sound. Okay. Got it. Nice. Thank you. Okay, is my screen visible now? Screen is visible, right?
Yeah, we can see your screen.
Okay, I'll play. I'll play for 5 seconds and then stop it. Just let me know if audio is also visible.
And itself requires lots of machines to serve all the different sites that you visit, but the process of crawling the entire...
Was it audible?
Yes, it's very much clear.
Very much clear, right? Okay, cool. I'll just play this video and let's quickly look at this video and then let's get back.
Web search requires lots of machines. The internet itself requires lots of machines to serve all the different sites that you visit, but the process of crawling the entire web, building up search indexes, and then having the machines available to quickly and accurately respond to search queries requires large numbers of machines. Last time I looked, I think Google operates millions of machines all over the world. And a lot of those machines are located in what's called data centers. So data centers are specially designed structures that are created to hold thousands of machines. And there are actually data centers pretty close by, but today we're just going to look at kind of a little mini data center that's located right in our own department. So this is one of the machine rooms that we have here at the UBCSE department. And let's go inside and take a look. Gotta use my card to get in. Okay, so let me show you a typical rack that you might find in a data center. So this is referred to as a rack. So you can see that it's a vertical structure, and inside this rack are lots of small computers. So each one of these computers each one of these vertical things right here with a label on it says Dell. These are each a server. And these are known as 1U servers. So racks have a typical style in terms of holding a certain, there's a certain set size for a server in a rack. You can see there's an empty space here. This is 1U or 1 unit. You can also get, like this for example, this computer is a 2U unit, so it's actually twice as tall. And they're sold that way so that I can buy a server from anywhere and I can install it into this rack. So this is the front side of the rack. This is showing me, you know, these computers don't have monitors, they're not really user facing, they're running servers that we're using to do different things in the department. So this, you know, there's no way to, you know, interact with these computers. This way you'd have to log in remotely in order to do things with them. So I can put lots of them in a rack. You can see there's some different configurations here. This one has a lot of disk drives, so maybe it's a storage type of machine. This one doesn't seem to have as many disk drives. I have no idea what these machines are for, but this is a pretty standard setup. So data centers around the world would be these huge buildings that would just be filled with rack after rack after rack after rack of holding, you know, hundreds of thousands of computers. Let's go back and look at the other end of the rack. So over here you can kind of see the business side of the rack, and this is where things get pretty complicated and messy because every one of these computers has an internet connection. These are all, looks like they're all Ethernet here, and they also need power. And actually that's probably one of the most interesting aspects of data center design. So why is it so loud in here? If we look up here, that's what's making all the noise. So there's a fan there, and that's a cooling unit, and there's another one over there, and there are actually other fans below the floor here that are circulating air constantly. Because computers, particularly when they're packed really tightly together like this, they generate a lot of heat. And so one of the interesting aspects of data center design is trying to make data centers energy efficient by trying to reduce the cooling cost. So there's a certain amount of energy that just goes into powering the machines, and then there's extra energy that you have to spend on the cooling. And after decades and decades, major internet companies have gotten very clever and very good at designing data centers in ways that limit the cooling costs as much as possible. One of the ways that you can do that if you're clever is you can decide where to put your data center. So nearby here in the Niagara region, we actually have some data centers that are run by Yahoo. So why would Yahoo decide to put data centers here? Well, there's a couple of interesting reasons. One is we have Niagara Falls nearby, and so we have a possible source of relatively cheap power that could be used to power all the computers in this area. The second reason, as you've probably heard, is that Buffalo is not necessarily a place that gets really warm for long periods of time. So if the surrounding environment is cold or cool large parts of the year, it costs less to cool the computers and the equipment inside those data centers than it would at other places. I just read that Facebook opened up a new data center, I think it's in Finland, probably for the same reasons. It's cold, climate is good, that limits the cost of power and to cool those computers. So data center, thousands of computers located close by. A typical data center might have multiple tenants, so it might have computers from a bunch of different companies. And the challenges in designing data centers are, really bound up in providing power, keeping the machines cool, and then also getting enough internet connections into the data center so that all the machines can have fast connections.
Okay, all right. Okay, let's exit the video. Alrighty, so I hope all of you understood, this video was quite interesting, right? I mean, how a data center would actually look like, right? And you understood what actually goes inside the data center, right? I hope all of you were able to see the video and was able to hear the audio properly. Okay, so all right. So so now just imagine, I mean, the gentleman when he entered the data center room, right? I mean, that's probably a small data center room that he was just giving us a very small demo, right? But imagine how big that room was, right? And how many racks it had, at least at just at a cursory look at the room, it looked like there were about 10 to 15 racks in it, right? And each rack had, I mean, he was talking about the U, correct? One U is one unit of a computer or a server that he stacks in the rack. It's called racking and stacking, okay? So when you stack one computer in the rack, that is basically one U, right? So similarly, I think usually racks come at a 42 U height. Okay, that's a standard size of a rack, okay, server rack. It's 42 U's. And then 42 U's, if you buy one U server, you can put up to about 40 servers in it. Okay, and each server can actually have a 64 core. When I say core, 64 CPUs. Okay, and 256 GB of RAM in it. Okay, RAM is memory. Okay, 256 GB and 64 core. Probably the Mac, the laptop that I'm currently using has got a 8 core 16 GB. Okay, so then probably it is like 10 times powerful than my one server that you put in one rack is about 10 times powerful than my local computer that I have, right? And imagine, I mean, in that room, he had about 10 to 15 racks. Each rack had, assume, say, 30 servers in each rack. Okay, there were 300 servers in that small room. Okay, and you saw that there were fans, huge fans rotating. So the moment he entered the room, you could hear that noise, a lot of noise in that room, right? And there were huge fans rotating, right, which would take away the heat that is generated. I mean, in my case, I can still feel that there's a lot of heat generated by my personal computer, by my laptop, right? But imagine a computer which is 10 times more powerful than my laptop. Imagine how much of heat that would generate due to the electricity, due to the current, and due to the compute power that it requires, right? So imagine tens of thousands of such computers sitting in one room. How much of heat would it generate, right? And on top of it, I need a very standard a standard electricity connection, right? I mean, uninterrupted electricity connection. Imagine how much of electricity you need to power all those computers, all those racks, all those rooms that you have, right? And it is usually, they don't go from the domestic electricity providers, right? Like what we have. I mean, at my home, power goes at least 2 to 3 times in a day, right? I mean, you can't afford to have that happen in a data center, right? In data center, you need a standard, continuous, consistent electricity connection, power connection, right? Imagine power going off every once in 2 hours, right? So that's going to bring down the entire data center down, right? It's not going to help. So imagine then you need two electricity connections to the, usually data centers have got two connections, two power connections from two different utility providers. Okay, if one is coming from one utility provider, the other connection would come from another provider or an entirely different grid, so that if there is a grid failure, the other grid will continue to provide a redundant connection to the data center, so that at least there is power coming from another grid. Okay, so then imagine how much of AC that you need in a data center room, and how many fans you need to basically remove that heat. Otherwise, if the room gets overheated, there are chances of fire coming in, right? And the computers, the racks could actually catch fire, right? And you know, and then they should be constantly 24/7. These data centers should be cooled. Okay, in fact, yesterday I came across a very interesting video. I mean, in fact, we knew about this, right? So where Microsoft, you know, built their data centers and then they put it under sea. Okay, the reason why they put it under sea is that the ocean will cool the data center much more efficient, and it's a more energy efficient option, right? I mean, imagine you build a data center on the land, you need to cool it, right? You need to cool the data center because of the amount of heat that it generates. And in order to cool it, you need ACs, right? And in order to have those ACs, you have to go with the conventional AC, correct? But a huge AC, right? I mean, the power, the cooling units that you see probably in, say, 5-star hotels or big offices, right? Where big buildings or malls, if you go to malls, the entire mall is cooled, correct? So that mall would have a huge, you know, air conditioning unit, right? Floor by floor, and that would consume a lot of electricity, and that is also not good for your environment, correct? Because the more and more of those you have, you're only going to add more to the carbon footprint, right? And that's going to basically have more impact to the ozone layer, right? So anyways, coming back, so what Microsoft did was they built their data center. It's a cylindrical shape, and then they immersed it under the sea. Okay, and then it's under the sea, so that, you know, the sea water would actually cool the surface of the data center, which would significantly keep the computers inside the data center to a lot more cooler. Okay, in fact, you can search for those videos. This just came up. So they pulled out that unit from the sea, under the sea, maybe a couple of days back, or last week they pulled it out, and they could see that, you know, there's no water leakage inside the data center, but a lot of moss and algae had formed on the outer surface, and they had to clean the whole thing from the outer surface, and then they had to again put it back inside. Okay, it's a very interesting video. You can it's there, I'm sure it's there on YouTube. You can watch it later. Okay, so now imagine, you know, if you have to build such a data center of your own, right? What would it take? It would take real estate. You need some real estate, where you have to rent a place like this, like what you saw in this video, right? Where you had to rent such a place, and you need to have power connection, not just one. You need two power connections, as I said, and you need AC. Okay, you need a proper air conditioning unit, and you need to ensure that you have the right fire suppression in place, like you have your fire extinguishers, you have your sprinklers, right? And within data centers, you can't have a water-based sprinklers, right? Because when there is smoke or fire, usually when you go to malls or offices, on the top you will see that there are sprinklers there, right? So what happens is, when there is a fire in that particular place, the sprinkler would get activated, and the sprinkler would be connected to a high speed pump, high power pump, which would pump water into that sprinkler at a very high velocity and speed. So that would basically sprinkle water all over the place, and then it would extinguish the fire, right? So that's a common technique that is used to extinguish the fire. But in data centers, you can't use water-based sprinklers. You need to have either a powder-based or a different kind of a fire suppression system that you need, right? and you need some monitoring for that fire suppression, right? And again, you need a building management system. That building needs to be managed properly, needs to be managed well, right? And any maintenance that comes up, it is responsibility of the building to basically manage that. Plus, you need personnel. You need people, who can manage these equipments, who can maintain these equipments. Like in this case, you saw that you had these many racks, these many servers in the racks, right? For example, one server, and these are all hardware, right? I mean, like how we have mobile phones and laptops or desktops, those could go bad, right? I mean, I can have a hardware failure. So when I buy, say, some Dell laptop or HP laptop or Mac, if I have some hardware related issues, I would actually take it to the service center, and service center will service it, replace the faulty part, and then give it back to me, right? Similarly, these servers can also go bad, right? But so now when it goes bad, they'll shut down, right? In that case, what you need to do, you need some people who can take that server, replace that server. Okay, so now you need people who can manage all of this, right? And you need, more importantly, people to administer all of this, right? So now imagine these are all cost at the end of the day, right? To build a data center, to rent a place. Renting a place would, you would probably need to spend say lakhs of rupees to rent a space, right? A commercial space, that too. And you need power, electricity connection to that space. Again, that would incur a significant amount of money expenditure. So then you need to buy all these equipments, more importantly, right? I mean, in this case, you saw this rack, it's from Dell, and you saw all these servers, they're all from Dell. You need to buy from Dell or any of the hardware vendors, buy all of this upfront. And Dell is not going to give you for a monthly EMI, right? Obviously, you have to pay all of this upfront. You have to buy all these servers, put it in your data center. You need people who can set up, install all of those, and you need you need to set up the air conditioning. You need to have power connection, and you need a network connection, right? You need, as you saw that, he was talking about each server being connected to internet or ethernet, right? And they will actually go through one common connection to connect to the internet, so that you can access those servers from outside as well, from your internet connection, right? Now they need internet connection, they need a high bandwidth 10 gbps or more than 10 gbps. They need that kind of a network connectivity to communicate with the world, communicate with the rest of the world, correct? So now imagine to bring all of this in place, it would incur a lot of capital expenditure. So when I say capital expenditure, I'm sure all of you know what a capital expenditure is, right? Capital expenditure is the first time investment that you incur when you set up your business, correct? Now, when I say I want to set up a small business, a boutique shop, right? And I say I want to set up a small shop, what I do is I go ahead or a fancy shop, or even, for example, for that matter, a kirana shop, right? I need a place, I need to buy all the goods that I want, right? I need to set up all of that, right? And that's a initial expenditure that you have, right? So that's called capital expenditure. So now all of the capital expenditure you need to incur, right? And then once you invest upfront and once you set up all of this, and then you go build your website, you deploy the website on all these computers at scale, right? So then then you can actually go for marketing. Then your marketing cycle starts. Then you start marketing that, okay, I've started a new e-commerce website, and these are the features of my website, and these are the discounts that I'm offering, these are the promotions that I'm doing, blah blah blah, and so on and so forth. And eventually, after that, you start seeing people are interested in buying goods or buying things from your website, and then you start seeing revenue. And then once you are successful, and once you hit the break even, right? Because all this would incur expenditure, right? And then you would probably go to 2 to 3 years in a break even period. 2 to 3 years, whatever revenue that you're getting is only covering your investments, whatever investments that you have made. Probably after, like, say, 3 years, that's when whatever investments that you have made, you have recovered all your investments through the profits that you have made. Maybe after 3 years, you will start seeing real profits over and above the investments that you have made. If you invested $1,000, you'll probably start seeing 1,000, the first dollar after the investment that you've made. Until that point in time, you are only recovering all your investments, right? And then on top of it, you will have a monthly expenditure, operational expenditure, such as you have to pay for the electricity bills, you have to pay salaries to the people that you have hired, right? And you have to pay maintenance to the building, correct? Where you have rented, or where if you have built your own building, then obviously that is also capital expenditure. Then you have to pay to the for all maintenance of your equipments, AC, your fire suppression systems, all your all your desktops that you see, or the computers that you see, servers that you see, it needs some amount of maintenance, right? So you need to pay for that. So all that will turn into a monthly maintenance expenditure, right? So now the reason why I'm talking about all of this is, I mean, you guys should understand, what is the, see, at the end of the day, necessity is the mother of invention, correct? There is a need. I mean, that would make people think that, okay, what would I need in order to fulfill the need of mine, right? So then that's how great products are built. That's how things are invented in the world, right? So necessity is always the mother of invention, right? So now, so that way, this is a very typical data center, right? And you can actually go through a lot of other videos. In fact, I'll open one more video of a Google data center.
A data center is the brains of the internet.
The engine of the internet.
It is a giant building with a lot of power, a lot of cooling, and a lot of computers.
It's row upon row upon row of machines, all working together to provide the services that make Google function.
Operating data centers. I'm Joe Cava, Vice President of Data Centers at Google. I'm responsible for managing the teams globally that design, build, and operate Google's data centers. We're also responsible for the environmental health and safety, sustainability, and carbon offsets for our data centers. This data center here in South Carolina is one node.
Yeah, so if you see this, yeah, you see the scale of this building. This is a data center building, right? I mean, this is Google's data center. Look at the scale, look at the size of this building, so huge, right? And you see on the top that you see here, they're all cooling equipments, correct? And you see, I mean, it has got so much of security, and it has got so much of, virtual and physical security aspects.
Data center here in South Carolina.
I am not sure how many thousand square foot this building
is one node in a larger network.
Node. That's what he's saying, right? There's a larger network, but the building that you see is just one node, one small node. They've got more such nodes across the globe.
Of data centers all over the world. Of all the employees at Google, a very, very small percentage of those employees are authorized to even enter a data center campus. The men and women that run these data centers and keep them up 24 hours a day, 7 days a week, they are incredibly passionate about what they're doing.
In layman's terms, what do I do here?
I typically refer to myself as the herder of cats.
And I'm an engineer, hardware site operations manager.
We keep the lights on.
And we enjoy doing it.
And they you get. So just to enter layers of higher level security, the closer into the center of the campus you get. We use various, and the privacy of our users' information is our foremost design criteria. We use various layers of higher information security.
Just look at that short video that comes up. That really shows the scale of the data center, right? Look at this.
Protecting the security and the privacy of
each is a rack. Okay, each is a rack which has got several servers in it. They're all connected to a common network. And I mean, I could see that. I mean, this long aisle that you see in the middle is like never ending, right? I mean, it just goes on and on and on, right? And now look at the scale at which, usually typically data centers like Amazon, Google, they offer, right? They operate it. Okay, so let's go back. Somebody has to go on mute, I believe. Yeah. Okay. So that's basically the power of you huge data centers. So now imagine you building a data center of this scale, and in order to host your business, it's next to impossible, right? I mean, look at the amount of investments that you would need to build such a scale of data center, and you won't be able to basically from a business standpoint, it doesn't make sense to invest so much in something where you can actually use it on a public cloud. Like for it's again a simple example of, I don't buy a flight just to go from one place to another place, right? In fact, I go book a ticket in a airlines, which is operating a flight. Similarly, I don't buy a train for myself. Similarly, I don't produce my own electricity, right? I go consume electricity. Of course, there are different ways of doing that. In fact, solar is there, but keeping solar aside, I don't, the conventional electricity that you have, I don't produce it myself. Rather, I go take a subscription with TSS PDCL, that is the Telangana's State Power Distribution Limited, Corporation Limited. Then I buy a subscription with TSS PDCL, and then I consume so many units of electricity. So whatever units of electricity that I consume, I pay only for those many units. I don't pay for the rest of it. If I use say 100 units in a month, I pay only for the 100 units. Next month, summer is coming up. Maybe in May, summer is coming up. April, May, I would need to keep my ACs on. So I would need to consume more units. So I pay extra charges during the months of March, April, May. Okay. So now it is what exactly is cloud computing, right? It's all about the change the way applications are developed and managed, right? What is all this hype about cloud computing? It's no more a hype. Okay, it's basically the reality, right? A specific computing style where everything from computing power to infrastructure, business applications are provided in a service as a service model over the internet. That's what cloud computing is all about. And cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources, such as network, server, storage. I spoke about this. I keep repeating this. So please remember that. It's a network, server, storage, applications and services that can be rapidly provisioned and released with minimal management effort or service provider interaction, right? What are those resources? They are applications, their system infrastructure, information, business process, and so on and so forth. So now these are the characteristics of the cloud computing, right? What is the characteristics of cloud computing? It is measured, like how you measure your electricity, right? And it is rapid elasticity, right? For example, if I'm consistently using 5 units, and if I suddenly need about 10 units, I'm turning on all my equipments at home, right? It is a rapid elasticity, right? Where I'm still able to consume that much power of electricity from the grid, and it's on demand, right? I mean, it's like you can provision your electricity connection, or it's like on demand. I mean, of course, electricity is not self-service, but at least partially it's on demand. But in the case of cloud computing, you register with AWS, you give your credit card details, and then you are good to go and self-service provision all the resources that you want. And broad network access, right? So where the moment you provision some servers on the cloud on AWS, those servers are actually connected to the internet. So you can access that from anywhere in the world. And it's resource pooling, right? So where the underlying resources that you have, it's not just only for you, it is pooled with so many other people, right? So that is the way these cloud providers, these massive cloud providers like Amazon, Google, Microsoft, they're able to meet the economy of scale. Why are they able to offer resources at such a cheaper rate, right? Because they are shared resources, and then you're only using a subset of that resources on the cloud. Similar to what I mean, why your public transportation, mass transportation is cheaper when compared to managing your own mode of transportation, because mass transportation is shared by masses, right? And you're only paying one portion of it. Apply the same logic there as well in computing as well. And in computing, you have different service models, such as your infrastructure as a service, platform as a service, software as a service. I'll come to these models a bit later. And infrastructure services where underlying infrastructure is offered as a service, where you get virtual machines, like which is virtualized. as a service model. In platform as a service, you get a complete platform, such as your you get a complete Java stack, right? You get a complete Oracle stack. You could get a complete .NET stack, right? And you get a complete LAMP stack available as a service. You don't have to worry about the underlying operating system and things like that. You get the complete stack. You start programming your logic, and then you deploy it in the platform as a service. Software as a services, you don't even worry about the stack or the platform that the software is running on, right? You just go subscribe to the software, and then you make use of it. Like Zoom is a software as a service. Gmail is a software as a service. Okay, there are humpty examples of software as a service. Salesforce is a software as a service. Okay, then there are multiple deployment models, such as you have clouds as public cloud, like the one that I just showed you, right? Where public clouds, Google data centers are public cloud data centers. Amazon's data centers are public cloud data centers. AWS is public cloud. GCP is public cloud. Azure is a public cloud. And similarly, you have private clouds as well. Like private clouds are within an organization, they build small clouds, which is called private clouds, and hybrid clouds is both a mix of both private and public. Community cloud is again where a certain community uses that cloud, right? Certain business community or a certain scientific community uses that cloud. Okay, so now why cloud computing? Why do you need a cloud, right? The reason is sprawling data centers. I just told about the data centers, right? Sprawling data centers, right? Huge. There are million square foot data centers. So now if you have to build your own data centers, obviously the cost is going to increase. You need to incur capital expenditure and operational expenditure. So and also increased operational cost on the data centers. Data intensive application, like explosion of user generated content, right? It's exploded multifold. In fact, in 2010, it basically hit zettabyte. Okay, now what we are speaking is like megabytes, gigabytes, terabytes, right? And all of us have got probably most of us would have a terabyte scale data, right? At okay, like in fact, I have got 2 external USB hard drives. Each is a 1 terabyte hard drive. In fact, 3 I have. Each is a 1 terabyte hard drive. Okay, and in fact, I'm like full of that. I mean, I have the data that I've been collecting over the last 20 plus years. All the data is there in those 3 hard drives that I have, right? I mean, as an individual, as a single person, I have 3 terabytes of data, right? Imagine across the globe how much of data will get generated. In fact, that's only the data that I'm storing. But if I even look at the data that I'm generating on a daily basis, like the photos that I take and the WhatsApp shares that I do, WhatsApp messages that I send, Facebook data that I generate, right? It's like huge data, right? I mean, in order to store and process this data, huge data, you would need compute power, right? And energy cost and green compliance, right? I mean, in this case, why an individual has to do all of this, right? So companies like Amazon, Google, Microsoft are doing this in a much more energy efficient way. If I were to do it on my own, I won't be able to necessarily manage the energy and the green aspects of it, right? And then better network capacity and availability, right? I mean, in this case, if I have to do all of this individually myself for my own business, I have to manage the network connectivity, right? I don't know when the network would go down, right? But in the case of cloud, they're managed at scale. So the network going down is basically a very, very remote possibility. Innovation and collaboration, right? I mean, in case I need more power and I've built my own data center with say 2 racks, okay? Now I need to do some POCs, I need to do some experiment. I need additional compute capacity, additional storage. Okay, again, I have to go buy more storage, buy more servers and put it in my data center. So that would need more cost, and that would more than cost. I may have the money, but in order for me to go buy them, place an order would take several weeks. Okay, if I have to place an order for additional 10 terabyte of storage, and if I have to place order for additional say 5 servers to be put in my rack, I need to place an order with Dell or HP or whoever it is, right? And they would take about 2 to 3 weeks to deliver that equipment to my data center. So now, if I were to do something quickly, it's impossible that I will not be able to do that in a quick time, right? But with cloud, that's not the case. You can go provision that additional compute and storage within few minutes, and you'll be able to innovate, and you'll be able to solve the challenge that you have, right, with respect to trying some new POCs and trying out. And once you're successful, you can present those results to your management and then deprovision those resources. When I say deprovision, you can just terminate those resources, like how I would do in the case of my home. I have a power connection, right? And there's a function that is coming up at home. I need more power to have more lights and have more floodlights and things like that, right? I would just consume that much, and once I'm done with it, I'll stop my consumption. Okay, and it's also shared across multiple various lines of businesses, right? So you can have a common compute environment which can be shared. What are the other benefits, right? It's pay-per-use model. So I spoke about the capital expenditure and operational expenditure, right? In the case of public clouds, you will not have a capital expenditure at all. Your capital expenditure is literally zero, right? You will only have operational expenditure, where for the amount of compute power that you use and the storage that you use, you pay monthly, but you don't pay upfront to a cloud provider $1,000 or $2,000 or $10,000 or $1 million, right? But whereas if I have to build my own data center, I need to invest that money to rent a space or buy a space and build all that equipment that you saw. So that is the difference. It's pay-per-use model, and it's on-demand resource provisioning, right? It'll increase your agility and flexibility, and you can just go anytime. You can provision any number of resources that you want, and it's elastic. That's why it's called elastic. You can grow and shrink. You can grow and shrink as per your need. Okay, you don't have to really worry about the capacity, because that all that headache is taken care by Amazon AWS, right? So where AWS takes care of ensuring that enough capacity is there in the data centers, in their data centers, so that you can make use of it as per your requirements, and faster time to market. And you will have a better time to market, and you'll be able to increase your productivity, and it's highly automated in nature, right? In fact, in AWS's data centers, there are even robots to change the faulty equipments with the new ones. Okay, if a server goes bad, even a human doesn't have to enter into the data center. There are robots which does all of that. I'm sure all of you would have seen the fulfillment center videos in Amazon, right? If not, please, in fact, towards the end of the session, I'll show you that video. How fulfillment centers are e-commerce warehouses, where when you place an order in Amazon.in, those fulfillment centers, it'll go to the fulfillment center, and it'll be shipped from the fulfillment center. It's highly automated. You will see robots in the fulfillment centers, which actually picks when you place an order in real time. Okay, it's a very interesting video. When you place an order, like for example, I use my app to place an order. Immediately the order gets processed, right? And you will see that workflow that's going on in the order, right? Order is being processed, order is being shipped, order on the way, order is delivered, right? So now when the order is being processed, what really happens is behind the scenes, it will actually go to your nearest fulfillment center. Okay, all that is decided by the algorithm. That fulfillment center, a robot actually goes to that particular aisle and the shelf where that product is there. It'll go pick up that product, bring that product to the bay where the fulfillment agent would process that order, and then it goes into a conveyor belt, and in the conveyor belt it goes to the next stage. It goes for packaging, and then eventually it gets shipped. Okay, it's a very interesting thing, right? I mean, it's all highly automated, right? So even in the case of cloud data centers, it's all highly automated. There's no manual intervention required, because there are millions of customers for Amazon, AWS. Okay, there are millions of accounts that AWS has got, right? And I mean, AWS can't put an individual human resources to meet all the requirements, right? So it's all highly automated in nature. Then a reduced server sprawl due to consolidation of, we saw this, reduced carbon footprint and more mobility, right? Now you can actually access information through mobile. You can access it from anywhere. I'm not bound to a specific network connection. Okay. And again, what is the difference between traditional computing and cloud computing? Resource provisioning, as I said, would take weeks, whereas here it's in minutes. Scalability, if I have to scale, elasticity, right? If I have to shrink and grow, you have to add resources manually, but here it's all on demand. The delivery model is you have to buy the assets, but in the case of cloud computing, you're only buying the service. It's very another common simple example is if you need to travel from here to high-tech city, in case of traditional traditional methodology, you have to buy a car. You have to pay whatever, 5, 6 lakhs, 10 lakhs, 15 lakhs to buy a car. Whereas with Ola, Uber, you just buy the service, right? Through your app, you go place the order, you this thing, and you place the ride, and then you're just buying the service. That is the difference, right? Flexibility, it's a traditional procurement model, whereas here in this case, it's self-service. Cost, additional yearly capital expenditure. I spoke about capex, additional yearly, but here it's just pay per use, no zero capex. You don't have to invest anything. Okay, you don't have to invest on Amazon, you don't have to invest on anything. It's just pay per use. Okay, again, this talks about the different models. See, at the bottommost is the infrastructure as a service, where you rent the processing, storage, network capacity, and other computing resources. Example is Amazon EC2. Okay, and there are a few scenarios. Then you have platform as a service. Platform as a service is a combination of infrastructure as a service plus platform. So where end users don't interact with the infrastructure directly, but they only interact with the platform. It's a software platform on which users can build their own applications and host them on providers' infrastructure. App Engine is there. Amazon has got Elastic Beanstalk and things like that. Okay. Then comes the software as a service. Software as a service is one layer above platform as a service, where it includes IaaS as well. But users don't interact with platform. Users don't interact with infrastructure, right? So use providers' applications over a network and saves the complexity of software installation, maintenance, and so on and so forth. Infrastructure services, where the traditional ways you buy hardware, you configure the hardware, you set up the data center, and then you manage and maintain. Whereas in benefit, there's no benefit there, right? So whereas in the case of infrastructure as a service, the processing, storage, network capacity, and other fundamental are rented out on need basis. You don't have to build all of that. And these are all the characteristics of infra. We saw about these. I'll not reiterate this. This is what infrastructure as a service would look like, where you have the underlying computing systems, network systems, and storage systems, and you have a layer of virtualization on top of it. And then you're able to basically interact with the virtualization system and build your EC2 instances or virtual machines, they are called. Like, I'm sure most of you would have done the VMware or VirtualBox, right? Oracle's VirtualBox. What it does, on top of your laptops or desktop, you're installing a virtualization software, and on top of that virtualization software, you're running a guest operating system, be it a Ubuntu or Red Hat or whatever it is, right? So that is the technology that is used in the cloud as well. It is virtualized on a physical hardware. There is something called hypervisor which is running. That hypervisor is providing the flexibility of virtualization. On top of it, you're building virtual machines, right? And those virtual machines are the ones where you're running your software or applications on. Okay, again, this is a virtualization. In fact, I'll give you this later. You can go through this offline. Okay, like you have your hardware. On top of hardware, you're running a virtual machine, which is either a Windows or Linux or whatever it is. Okay, again, there are benefits of and challenges of infrastructure as a service, but infrastructure as a service is the foundation layer of cloud computing. Okay, a lot of you would actually see that. And who are the IaaS providers? So these are all the IaaS providers who offer infrastructure as a service. Again, platform as a services, you have IaaS, but how do you build applications on top of it, right? That's where you need a development platform which has got a development environment. You need some hosting runtime, right, and things like that. to which developers can connect to and start building their code. Okay, so that's platform as a service. Okay, and benefits of platform as services: developers can focus on their application code and the business logic, and it's a natural fit for development, testing, and production environments, right? Where you don't have to worry about the underlying infrastructure. Underlying infrastructure is managed by the cloud service provider. In this case, Amazon manages it. Whereas in the case of IaaS, Amazon only manages the hardware layer, but the operating system layer needs to be managed by you as an individual. Again, software as a service. So you have infrastructure layer, you have the platform layer, okay, but you need the software. What is the missing piece that and how it looks like? That is software as a service, where you can straight away go Gmail, right? Gmail is a SaaS. You can straight away go to Gmail and create an account for you, right? Everything else is managed by Google, like the underlying hardware, the underlying platform. It's all managed by Google. You don't have to worry about it. Okay, it is basically used for CRM. Like for example, I've started a new business and I need a accounting software, right? I don't need to I don't need to build computers or hardware to host my own accounting software, right? I can simply go to Zoho. Zoho is a software as a service, right? All of you would have seen Zoho, correct? It's a very famous SaaS company. Okay, Zoho has got many products. Okay, it's a complete CRM platform, right? It has meetings, it has so many things, right? You can just go to Zoho, and this is their portfolio of services that they offer. Okay, similarly, Salesforce is another software as a service which comes out of the box, right? In this case, Zoho, you go sign up with Zoho. Yeah, you can just go sign up, and then you can just log into Zoho and then start using an accounting software from day one. You don't have to wait for all the other building of infrastructure, building of the platform, building of the software, and things like that. Okay, multi-tenancy, right? Again, multi-tenancy is another important concept that all of you should understand. Okay, we know the differences between living in an individual house versus living in an apartment. Okay, if you're living in an individual house, okay, what you have is you have that entire real estate only for you. That building is only for you, and you have your electricity connections, or you have water connection, right? Water connection is only for you. But whereas if you live in an apartment, okay, in the apartment, huge apartment complex, there are multiple people multiple tenants who are living in that apartment complex. Each of them live in their own flats, and each flat is like is separated by walls, correct? And a person from my neighbor cannot enter my flat, correct? And I can't enter my neighbor's flat without authorization, correct? So that's the difference between a single tenant and a multi-tenant model, right? And also, if you take, for example, when you want to, so the water resources, right? The water pipelines that runs between these apartments are shared pipelines, correct? There's no dedicated pipelines that go, right? There's a shared common pipeline that goes for my apartment and my neighbor's apartment, right? So that's the difference between a single tenant model and a multi-tenant model, right? So where in a single tenant model, each tenant gets a dedicated software stack, and each layer and each stack requires configuration, monitoring, upgrades, security patches, tuning, disaster recovery, etc. Whereas in a multi-tenant model, you have a shared infrastructure. In this case, an apartment is there, lift is shared, water connection is shared, the common area that you see, they're all shared, right? The park, you might have a park, a play area in the apartment, in your gated community. So that is the shared infrastructure. Whereas the core of the compute itself is not shared. That is, for each, but the underlying hardware is shared. But the virtualized instance that comes on top of it is not shared. In a multi-tenant environment, all tenants run in a single logical environment. So logically, I live in this building, logical building, but I live in a small apartment called whatever 1208 or something like that, right? So any upgrades or improvement appears to all tenants at once simultaneously. For example, lift is being upgraded in my block. So it will impact everybody, right? Not just only me. It will impact everybody. It will any upgrades or improvement appears to all tenants at once simultaneously. As a result, they are faster, secure, better available, automatically upgraded and maintained. And we have got a security guards, we have got watchmen and people, who can basically manage all of this. So that's the difference between a single tenant and multi-tenant. So don't get too worried if you're not understanding it. You'll get more idea of it once you start a deep dive. Okay. And if you see, as a system administrator, I will deal at an infrastructure as a service layer. As an application developer, I deal at a platform as a service layer. I don't have to worry about infrastructure. I only need to worry about the platform and the code that I build. As an end user, I only deal at a software as a service layer. I don't worry about platform and infrastructure. Okay, a lot of other, as a service models that are there. Again, cloud deployment models, I spoke about this. Let's skip it. So what is new in cloud, right? I mean, is it a old wine and new bottle? No, right? I mean, it's not the case, right? And the new thing about cloud is it's about the scale. The scale is pretty huge, right? I mean, you just saw a few examples of few data centers. That scale, no individual will be able to operate at that scale. No individual organization will be able to manage that scale unless you have billions of dollars of surplus money with your business, right? Unless and until you have that, you want to spend on doing this undifferentiated heavy weightlifting, you don't need to, right? I mean, and simplicity offered by the cloud is new, right? Where you just need a credit card, 5 minutes, and you have a computer ready to work. You will see that. I'm not hyping this. I'm not exaggerating this, right? You just need one credit card and you need 5 minutes of your time. You can have your computer ready to work. And it's all elastic. Okay. It's like one computer in a rack for 120 hours versus 120 computers in 3 racks for 1 hour. That's the difference, right? You can rent 120 computers in for 1 hour. At the end of the day, you need 120 hours of compute, correct? So you can either go with one computer in a rack for 120 hours, which is your own private model. Whereas in a public cloud model, you have 120 computers in 3 racks for 1 hour. And you only, you can do that compute that you want to do for 120 hours with one computer. Whereas if you want to do it for 120 hours, it would take how many days? 4 days, 5 days, or 6 days. Okay. Whereas if I want to complete that entire job in 1 hour, you can provision 120 virtual machines, split the work between these 120 virtual machines. You can complete the day work that you want to do, compute that work that you want to do in 5 days in 1 hour. That is a difference. That is elasticity and usage-based pricing. Okay. And these are a few scenarios. I'll not go too deep into some of these scenarios. There are a few myths that cloud computing has, right? Cloud computing requires virtualization. Okay. Although virtualization brings some benefits, it is basically not a pure requirement. I mean, of course, virtualization helps in virtualizing the underlying requirement. And cloud computing requires you to expose your data to the outside world. Not necessarily, right? I mean, it's up to you whether you want to expose the data. So people say that cloud is not safe, secure, and all that, but all of those are gone. I mean, they're no longer relevant. In the current 2020, the cloud offers better security than managing it by yourself. Okay. And yeah, I mean, that's basically some of these. I don't want to go too deep into some of these. Again, challenges as such, there are no challenges with cloud computing, but there are a few things which could pose challenges. One is regulations and legal considerations, right? Like, I'll give you one simple example. In India, Reserve Bank of India, right, which is the governing authority for banking system in the country, they have mandated that any payment service, online payment service like UPI or which uses payment like Google Pay or Amazon Pay or Paytm, the data has to be processed and stored only within India. Okay, so now in case of cloud computing, you have a choice to store the data in India or outside the India also, right? In India, you have in Amazon has got a region in Mumbai, data center in Mumbai, so you can as well prefer to choose to store the data in India itself. Okay, but by mistake, if you store it in Singapore region or US region, then you will be non-compliant. So you have to ensure that you meet the regulation and legal considerations of the local laws, right? And also, security, again, as I said, is not a concern, but it's again depends on you, how you expose your data, right? As a consumer of the cloud, right? If you ensure that you adhere to all the security considerations, your data is secure. Okay, leave this. So that's basically, a quick, I said I'll complete in half an hour, but I couldn't resist. But yeah, that's a introduction to what cloud computing is all about, right? I mean, what are the different models of cloud and what is a data center, right? I mean, you need to understand what does the data center comprise of, right? I mean, it's not something, it's not a fun, it's not a, thing. It's fun, of course, but it's not something which is simple to think, right? Like what we would think, right? I mean, you think that, I mean, cloud is there. AWS is offering some services, you just go and use the services, but you really need to know how those services are built, right? What powers that services behind the scenes, right? I mean, you need to understand, how those data centers look like, right? And what is the scale of those data centers which is offering the public cloud service? What is the scale of Amazon data centers, right? So now, as promised, I'll just quickly show you that fulfillment center video so that you understand. Yeah, okay, this is what I was referring to. I'll open this. Open this.
Good grammar and spelling are important, but if you want to write essays that
You just saw the automation level of automation that a fulfillment center in Amazon actually has implemented, correct? So now all of this that you see, the robots picking up the packages from goods from multiple different aisles, and then it's putting it in the conveyor belts, and it finally gets ready to be shipped. That all this data is actually processed in the cloud, even by Amazon, right? Amazon, although Amazon and AWS are part of the same parent organization, the Amazon as a business, the e-commerce business, is making use of AWS's own cloud. Right? We are dogfooding ourselves, right? So out here, we are dogfooding the power of AWS within Amazon's fulfillment centers. Okay, so that's a small example of how automation is actually used, and a lot of AI ML is being used, right? Like you saw those robots moving from one place to other place, right? And you saw those robots kind of picking up this thing, and it's all going in a structured way, correct? So now all that is basically powered by AI ML, and they're all processed on cloud. Okay, so there are so many videos like that, and in fact, I'll just show you one more video of AWS data center. Okay, okay, this will be quite interesting. It's probably an animation thing, but it's not. You have seen the real data center video, but look at this. Yeah, see, 120,000 physical servers, which is 1.2 lakhs. 8 million customers are actually using this. 8 data centers. See the bandwidth of all of these data centers, 2000 Gbps, which is huge, right? The bandwidth is unimaginable. You see, that is the physical location of one of the data centers. Okay, and what you're seeing is a map view, a bird's eye view of the data center, but it will further zoom in and you'll be able to see the scale of the data center. Yeah, so it is next to a dam, hydroelectric dam. So that dam, which is actually producing renewable energy source, so that it can continuously power the data center, and it's close by, very close to the dam, right? And there is a power generation company who is generating power, and it is like basically powering this entire data center using this renewable energy source, so that it is environment friendly and it's green. Yeah, and there's a substation nearby, 120,000 volts substation, which is close by. Yeah, I told you about this, right? So this data center has got 3 different electrical supplies. One coming from the dam, which is close by, which is producing about 120,000 volts. And there are 2 more redundant connections which are coming from different sources altogether. So for example, there's some technical glitch with this, you will still have your power connection coming from 2 other sources. So that is the kind of redundancy that is built in some of these massive hyperscale data centers that Amazon offers. highly secure location in terms of physical security. Nobody can enter that. So this is one hosting tower. Okay. So you see these 4 rows of strips. Each strip is probably, I don't know, maybe 1 million square foot or so. I don't know, I'm just guessing. I don't know, it could be more. But each hosting tower has got 10,000 servers in it. This is just one hosting tower, which is probably one, maybe 3-story or 5-story building. Okay, that is one hosting tower. That's called a hosting tower. Maybe it's about, yeah, maybe a 5-story or a 10-story building, right? And that building can host about 10,000 servers in it. Yeah, you see one strip has got 12 hosting towers, which is about 120,000 servers. Just that one strip. A total of 36 hosting towers. Okay, put together, they can host about 3.6 lakh servers. Yeah, this is what I told you, right? I mean, they're zooming you into the one of the hosting towers, right? What that hosting tower would look like. If you see that, it's basically a 3 or 4-story building actually. Yeah, see this? It's probably a 3-story building. 1, 2, 3, maybe one more ground, maybe 4, 3, G+4 or G+3. Yeah, these are all your racks that you have. And this is where you're probably, if you in the next subsequent sessions, I'll make you provision one server. Okay, on EC2, one EC2 instance. I'm sure a lot of all of you, most of you would have done that previously. But when you remember that when you provision one server, it would actually find its place in one of this mega scale, hyperscale data centers that Amazon runs. I'm sure you would have got a sense of what I'm talking about. Okay, so now, so that's the scale at which cloud operates, right? And at some point in time, you will see that any data that you come across, any data that you generate on a daily basis, you're storing it in cloud, and your cloud is instrumental in processing that data, and cloud is instrumental in managing and helping you store that data. Okay, so what I would do now is I'll just take a pause here, right? What you guys can do is you can read more about basics of cloud computing, right? Do that today, right? And maybe you can watch some videos that are there, some interesting videos. I mean, you have to get excited. That's all I want you to do. Okay, so that it can give you enough fuel to learn, and it will induce the excitement in you to actually learn and be part of this massive journey that the world is experiencing today. Okay, and you can think of it as a great opportunity to kind of even get exposed to what others have built, right? Of course, at the end of the day, all of us, we have to aspire to be builders, right? We have to build similar things, right? And we have to basically aspire to make use of the technology to improve the lives of people, right? And build innovations and and also understand that, such a scale is existing, which you can make use of, right? So that's all I want you to do. That's why I'm emphasizing a lot on watch some of these, right? It'll really improve your knowledge. It'll enhance your knowledge, right? And you'll be able to talk much better, tomorrow when you actually face interviews, right? And when somebody asks you a question, what is the scale of cloud? You'll be able to give a good 5-minute answer on response on what the scale of cloud computing is all about. Okay, so read and watch these videos, and you can understand how this works, right? And I'll give you this PPT, right? I'll post it, so you can go through this offline, right? Or maybe in today's assignment, maybe in the breakout session, read this whole thing. Okay, and there are some links put underneath it, so you can glance through those links. Each slide has got some links underneath it. You don't have to master all of those, but just glance through as and when it's required. Okay, at least the ones that I've put in, important ones, just go through that. Okay, and from tomorrow, what we can do is we can get started with AWS, and we'll have some lab sessions done from tomorrow onwards to accounts, provision the first EC2 instance. I'll tell you what an EC2 is, what an S3 is, what an EBS is, and things like that. We'll start with that, and then, but for that, today you spend that time in doing this homework. Okay, all right. Any questions, guys, on any specific questions on the scale that I just spoke about and the cool things that you just saw right now? Only related to this. Rest of it, we can take it in the subsequent sessions. In fact, in Mumbai, we have got a data center like this. Amazon has got AWS has got a data not just one, several data centers like this, which put together is called the Mumbai region. Okay, if you provision resources in India, it will be in Mumbai. Okay, and there's one more region which is coming up in India, so it will be announced very shortly. Any questions? Any curious questions? Please feel free to ask. I'm sure all of you got a hang of it. Yeah. A04.
Sir,
yeah.
what is the difference between AI and cloud computing?
Okay, so AI is basically a technology which brings artificial intelligence into computing, right? Into the world of technology. But cloud computing is basically a platform where you saw this. In order for you to implement AI, you need some compute power, right? Without compute power, you won't be able to implement AI. Okay, so now cloud computing enables you to implement AI in a very cost-effective and efficient fashion.
Okay, sir.
Okay, yeah.
Hello, sir.
Cloud is the basis for everything. Yeah.
Hello, sir. Actually, I have got a doubt on how actually technically connect two servers. As you have said that by 5 hours we can 5 hours work, 5-day work we can do in 1 hour. So technically possible.
Okay, it's like this. Okay, I'm building a house.
Yes, sir.
Okay, and assume I'm a worker by myself, right? I am able to. I have the necessary skills to build my house by myself. Okay.
Yeah. Okay.
If I were to do the entire building work all by myself, how long would it take? It will take several years, correct? Yeah, it will take longer, right? But rather, I bring more people, more skilled people, and parallelize the effort. Okay, because each one will focus on one thing, right? One person will work on laying the foundation, the other person will start looking into the carpentry work, the other person will look into the plumbing work, correct, and other person will look into the other kind of painting and things like that, right? So now that's where the distributed computing plays a major role. Okay, today we live in the world of distributed computing. There used to be a time when everything was done by one computer itself. It's called monolithic, but we no longer live in the monolithic world. We live in a distributed world. So that distributed world, you have to distribute work between multiple servers, so that a quantum of work that would involve 5 days of or 120 hours of work, if one computer had to do that 120 hours of work, then it would take 5 days, correct?
5 days.
But if you distribute that 120 hours of work to 120 computers, you can complete it in 1 hour through parallelization.
How exactly it is distributed, sir?
Okay, so that is where okay, so now if you look at distributed computing, there are certain mechanisms in which you can run parallel programs in a distributed computing, like Hadoop, for example, right? Hadoop is an example, a classic example of the distributed computing.
Okay, we first install the distribution software in first.
Yeah, correct.
In the all
correct.
servers, sir, actually.
Correct. Yeah. So don't worry too much about it. Just understand this concept. Rest of it, you will get more clarity as and when you.
Yeah.
Hello, sir.
Okay. Yeah.
Hello, sir. Sir, why we are choosing AWS? Sir, we have different types of clouds like Microsoft, Azure, IBM, and so on. Why?
Yeah. Very good question. Very good question. So yeah, I mean, it's up to an individual companies, enterprises, strategy to go with a specific cloud provider. Okay, there are various other cloud providers that are there, but my justification of why somebody should use AWS is because AWS is the one which initially commercialized this entire cloud computing model into the industry. Okay, way back in 2005-06. That is number one. Number two, AWS has got the maximum number of services, okay, which is required by enterprises as compared to other cloud providers. And AWS has got the max market share, right, with respect to being a successful cloud service provider. Okay, so these are the reasons, and also the cost of AWS is competitive when compared to other cloud providers.
Okay, sir.
So these are the benefits of why somebody should go to AWS.
Sir, this all
having said that,
software.
Yeah, sorry, but having said that, it is an individual and enterprise's strategy to choose their cloud provider. Yeah.
Sir, this all similar, sir. My MS Azure, AWS, and Google Cloud Computing. How much it is similar, sir, to each other?
Okay, I will ask you. Okay, I will ask you another question, counter question. You have so you have a Hyundai car and you have a Volkswagen car, right?
Okay.
What is the difference between a Hyundai and Volkswagen?
Luxury.
What capabilities they deliver? What capabilities they deliver?
Speed and in terms of
both. No, the basic capability that both the cars deliver is it gives you a mode of transportation, right? Yeah. You'll be able to travel from one place to another place using these two cars, right? Yeah. But the flavors vary. The flavors of both Hyundai and Volkswagen vary, and some of the additional features that Volkswagen and Hyundai may give may vary, right? For example, Hyundai may give additional security features, or Volkswagen may give additional security features, right? And Hyundai may have better efficiency, or Volkswagen may have a better efficiency in engine, right? But and at the end of the day, the peripheral features would basically change from one car to another car, right? That's number one. And so in the case of cloud also, there are features that vary from one cloud provider to another cloud provider. It's not just about features, right? It's all about support as well, right? Service support, maintenance, and so on and so forth, right? So all of those might vary from cloud provider to cloud provider.
But the terminology is same in all the.
The terminology. Okay, between Hyundai and Volkswagen. In Hyundai also you have a chassis, you have 4 wheels, you have a steering wheel, clutch, brake, gas pedal, and so on and so forth, right? And similarly in Volkswagen also you have that fundamental terminologies, compute, storage, network is same across. But in Hyundai, they call a certain engine feature with some terminology. Volkswagen may call it differently. That's all. Okay. One more example here is in Amazon AWS, the infrastructure as a service, the virtual machine that you provision, it's called EC2, Elastic Compute Cloud. Whereas in Microsoft Azure, it's called virtual machine, VM. Okay, that terminology might vary, and the way it gets provisioned, the way you interact with the console, like in AWS, the console that you see, right, where the web page that you see, that is different. Whereas in Azure, the console is different, similar to Ola and Uber, right? Uber has user experience, certain user experience, whereas Ola has got a slightly different user experience. But both work the same way at the end of the day. Both deliver the same set of features. Maybe sometimes Ola is cheaper than Uber, so people may prefer for Ola.
Yes, sir.
But at the end of the day, capability, the business capability that both provide is one and the same. So that's the difference that you need to understand.
So basically, this all works on under the virtualization, and the base actually we'll install Windows or Linux OS in our personal computers. But in servers, what we will be installed initially to access this all Windows or
Linux or Windows only. It'll be Linux or Windows. Yeah.
Yeah, but some companies will like on Windows. Some companies
they can also
like on Linux.
They can also install their own operating systems. That's not a problem. So in infrastructure service, they can install their own operating systems, and they can use that.
Okay. Initially, we should select the options that what will we like to operate.
Not necessary. Not necessary. I'll explain all of that when we come to that. When I show you EC2 demos, I'll explain you all of that. Not necessarily. Okay. Yeah.
Okay.
Sir, can you give a brief idea of what's the role of cloud in our Zoom call?
Okay. So now, so this meeting is hosted. Okay. This meeting is hosted by Ravi Shankar. So it is his Zoom account. I believe. Yeah. So now, what Ravi sir would have done is Ravi sir would have gone to Zoom, and he would have subscribed to Zoom, and he would have created an account in Zoom, right? And then after his account got created, the ID that you see, right, whatever 538015, or the part, this thing that you get, the unique ID, you will get from Zoom, right? So now, actually, what happens is when Ravi sir has hosted this meeting, when he has started this meeting, what will happen is behind the scenes, the necessary streaming software, the audio and video streaming software, online audio video streaming software that is necessary to be spun up will be spun up in a cloud environment on demand, right? When he clicks on host meeting, or when he starts the meeting, immediately within a few seconds, what would happen is all the necessary software and the applications that are required to make sure that I am talking, or rather I'm showing my video, or I'm sharing my screen, all of that will go to the cloud on those particular set of servers, which is hosting this particular meeting. And then from there, whoever logs into that, right? For example, in this case, 106 people have logged in, 105, excluding myself, have logged in into this meeting. So all the 105 people will be able to stream the data from cloud to their personal computers or mobiles or desktops. Okay, but all of this data first goes to the cloud. It gets processed there over internet, and then from there it comes to the devices. So that processing needs to happen there, right? Because if we are not allowing any unauthorized persons to join this meeting, if say for example, another new someone is trying to basically log into this particular meeting. So what he would do, he has that URL, but he doesn't have the password to log in, right? So now when he tries to log in, it would allow him to go reach that server where he can go hit this URL, get the pop-up, and then say that it'll ask for his name and participant password, right? So now in this case, unless and until he enters the participant passcode, he won't be able to log into that meeting. All of that business logic is running within that software, which is actually running on the cloud. The meeting ID that he hosted, when he starts the meeting ID, all of those softwares are come up on the cloud on demand. Okay, and it will allow users to connect to that provided they give the password. So that's how, cloud is actually used in the context of Zoom meeting that we are currently talking on. Now, every packet, right, I'm talking now, right? Every packet of the audio packet that I'm talking is actually going to that server. It is getting processed by that server. Now, what that software does is probably, that is again custom software, right? It's not something that cloud is offering. But what cloud is offering there is, cloud is offering the necessary compute, storage, and network required to process this software. Okay, and what the software does is probably it applies some codec on top of it, some audio codec on top of it to eliminate noise cancellation and things like that, and then it sends it to your laptop or desktop to the rest of the 105 participants who are connected to this meeting. Okay, but the necessary compute, storage, network needed to run this meeting is offered by the cloud.
Thank you, sir.
Okay, maybe we'll take one more question if somebody has, and then we'll wrap it up. You all can go into your breakout rooms and okay, all right. So then what we'll do is I'm going to send this PPT in the chat. Okay, I'm going to paste it in the chat. You'll all be able to get it and go through this in today's session, today's breakout session, and go through the links that are provided so that you get an idea. So tomorrow what we can do is we can get started with a little more on doing some hands-on work with AWS Cloud. Okay, sounds good. I'm just sending the document. Okay, here you go. It is sent from my side, so you should be able to get it and start with that. Okay. Okay, all right. So then thanks all for joining today, and thanks mentors, and thanks host for hosting this. So let's catch up tomorrow. Maybe you all can go into your respective breakout sessions, and maybe you can collaborate there and start reading this that I've sent. And then we'll catch up tomorrow on specifically on AWS. I'll start introducing AWS, what services AWS has, and we can do some demos as well tomorrow. Okay. All right. Thank you. Thanks all, and Sairam. Have a good day.
Thank you, Anand.
Thank you. All right, over to you. Thank you. Over to you, Sai Krishna, brother.
Thank you. Friends, please join your respective rooms.
Thank you, Anna.